Welcome all. Good evening to all. We'll just begin with the next webinars, that is AWS Serverless. This will be a part of a webinar AWS series that we are starting with. So I welcome you all for the second session. A gentle reminder that we will be having a next session on coming Friday, and thereon it will continue on every Friday at 5 IST, 5:30 BST. Okay, so let's begin. So when we hear about serverless, so what it actually means. So let's understand what is serverless. So serverless is nothing but a way, a method in which you are using the resources of the server, but without actively managing it. So it is a model in which you allocate your cloud resources on demand, and then all those resources act as a underlying hardware and a request portal where you make your request. So there are various ways you can work with serverless. So AWS provide a method by which you can make your own APIs and work with serverless. There are different applications which you can build over a go, and you don't have to wait for the entire architecture or the underlying hardware ready for you. So you have your things like the hardware and the infrastructure ready for you to directly work on the actual product or the application. So what are the different serverless services that are provided by AWS? So first one is Amplify. So Amplify is a hosting platform or a tool that helps you to provision different cloud resources like API gateway, Lambda, or if you want to use AppSync or authentication. All those services are defined and deployed on Amplify, and you can have your application hosted on Amplify using their storage platform. So there are multiple ways you can use Amplify, one with CLI and one with the admin view. So with CLI, you can create your resources like API gateway, define your function with Lambda, or add authentication and add the storage. Similarly, you can have your front end connected with Amplify such that your user-oriented application or user-faced application will be directly accessed using that URL. Next is the S3. S3, as I mentioned earlier, it is used for storage. So if you want to store your static data like images or your JSON data or different videos, then all those resources you can store in S3. Next is Cognito. So Cognito is something which you can use for authentication. Now normally when we work with websites, we tend to have different sort of user management softwares, or we have to write our own code to work with user management to authenticate those users, or allow a method wherein they can sign in. So all these methods are supported by Cognito by itself. So you don't have to actually work with hashing or securing your user authentication platform, or you don't have to actively manage different users or store the user information like password. All those things are managed by Cognito. You just have to add the authentication using Amplify CLI or the admin Amplify view, and you will have your authentication ready to be utilized or deployed on your application. Next is API Gateway. So API Gateway provides you a method wherein you can define your REST APIs, or you can define other socket layer APIs which you can directly use in your application when making a call to your data like your storage or the data which is stored in the database. Okay, so it is like a interface or the front end, you can say, from where to the portal where you will make a request So API gateway is very important when you work with serverless application because all the data that needs to be pulled dynamically are pulled using API gateway. Next, if you want to work with business logic or complex algorithms, or if you want to uh, work with the data that you get in the request, or you want to process the information that you receive on your application. So Lambda is a service that helps you in writing a code that will execute the sequence of operations which will process your data as per your need, or even if you want to store the data in the DB, then Lambda allows you to make a request to uh, either of those DBs like DynamoDB or Aurora Serverless. So it just makes a call to database engines, and you can then send that information to be stored in database. So practically when you work with serverless, there are two different database engines that you will use. So first one is NoSQL, that is DynamoDB, wherein there is no direct connections, or when you are not sure that okay, if you want your data to be related to one another, or if you want to just grow with a new attributes or new entities that you will keep on adding as per your application requirement. So DynamoDB helps you in writing or creating an application that will scale easily, and you don't have to much worry about making different connections, or you don't have to much worry about the amount of data that needs to be stored. Second one is Aurora Serverless. So normally, to overcome the problem of defining the relationship between the tables, so in Aurora it works similar to MySQL or Oracle or SQLite, all those different type of database, or Postgres, or all these different type of database engines you can use with Aurora Serverless. So it also helps you in replicating that information all over the world, such that if one of the database engine or one data center, what we had seen in the previous session, so one of the data center, if it goes down, then you can use another data center wherein you have replicated your database. So you can make a application call to another database in different region effortlessly. So this is a very good advantage of Aurora Serverless. Next is AppSync. So AppSync allows you to make a graphical API request using AppSync service to make a database queries, or if you want to process your data and send that data to the database, then AppSync help you to make that request or send that information into the DB. Next one is Kinesis or Kinesis. So basically this helps you to process the data in real time. Now if there are third-party applications wherein you are gathering some information from different sources, and if you want to do some analytics, like you want to check what this data is all about, or how this information will be used in determining what, like in terms of pharmaceutical companies, if there are different samples that are sent to the laboratories, so it is quite tedious to analyze all the samples at once. But if you have some sort of data available with you, and if you want to process that set of data with a basic algorithm, like what type of disease the community or the in a particular region people are suffering from, or what are the lack of nutrition they have, all those things can be processed in real time using Kinesis data processing. Also the real time score or the leaderboard processing, it can be done using Kinesis. The next one is SNS. So if you want to send the notifications, or if you want to send the emails of to your customers or at different platforms, then SNS comes in handy, wherein you can process your Lambda. You can use SNS in Lambda and process the email or send an email to the customer or send an SMS on the mobile devices of the users. So let's look into much deeper how you can work with different layers of serverless. So the diagram here will give you an overview of how different layers come into the picture when we work with serverless. So one of the primary layer is content distribution layer. So it is nothing but your domain where your user will go to, or the traffic that you will receive on your site. So if you have large user group or many people who will be using your application, then and if your user base is not just limited to one country or one region, but if it is a worldwide user base, then this CloudFront service of AWS helps you to reach all those users with lowest latency. So you can reach your user with at much faster rate, and even the information processing is much quicker. Even the data of your site, like the files or the content on your site, will be displayed to the user at a much faster rate. Next one is the API management layer. So here we work with Amazon API gateway. So whatever the incoming traffic that makes a request for a particular resource or any data, it goes through this API gateway and it makes a REST API or other types of API call depending upon your application. Then we have data layer. So data layer is distributed into two types. One is your images or your static content that needs to be stored. So it goes to Amazon S3, that is simple storage service. Or if you want to store the metadata or the information into the database, then the Amazon DynamoDB or RDS, that is the Aurora service which you can use. Next is the integration layer. So sometimes it may happen that while working with your application, there might be a multiple request from the different users all over the world. So there will be an overload on the API request, or there will be a delay that might happen on your if your application is of e-commerce type, and if you want to process a real-time scale or the checkout process, then some of the information may be lost. So to handle that, we have the special services which we can work with. The first one is Amazon SNS. So apart from sending the SMS or sending the email, SNS also helps you to send a real-time notification to other AWS services where you can process the application data, like if there is an email or if there is a mobile number of the user, how you can use that information and create a new record that will be unique for that every user. So next is Amazon SQLs. So SQLs allows you to process the API in a queue form. That is, when you make multiple API calls, like if there are multiple users who are accessing your site, and if there are multiple data entries that need to be processed, so all will be kept in a loop, and it will be all chained like in a stack. So in SQLs, all those stack will be processed one by one until all the requests are fulfilled. So you may not lose the data that is being required to process your request. So this SQLs is a very good service when you work with very application where there is too much of traffic or there is too much load on your website. Next is the event bridge. So if you have many events set up, like the real-time information processing, so in the previous slide I had given an example of Kinesis or Kinesis. So if you want to process the leaderboard in real time, like if there are multiple teams playing, and if you want to keep track of the score at different levels. So now whatever the event that is being processed, or whenever there is a change in the score, so to keep this to use this information, like the change that happened in the score, and use this information to process any other software. Like there can be a software wherein I have my website showing the details of the rankings, okay, and I have my another application where I am just allowing the user to enter the information such that if there is a score update, then they will update that score. But I also need to show that information in real time, like as and when the user updates the scoreboard on his end, that is the back end of the application, then on the front end it should be shown real time. Or if there are two different applications which are independent from each other, okay, so there is no direct connection between these two applications. So Event Bridge helps us to send that data from your application or any third-party apps that you may use, like the Zendesk or the other services wherein Zapier. So all those different services you can integrate with your application using Event Bridge. So whatever the events that are triggered on your application can be sent over to the another application where you will work with that information. So Event Bridge becomes like a chain or a bus where you have a lot of data based on the events that occur. Okay, so SQS and Event Bridge works similarly, but they have their own importance when you work with the type of data you need to use. Okay, and the last one is the final, where you want to process the complex logic or your business logic layer. So in here we have two services which you can use to work with. The first one is AWS Lambda. So Lambda, as I mentioned earlier, you can process your information that is being pulled from the API gateway or from S3 notifications or from SQS or from the Event Bridge. So Lambda allows you to make a connection with multiple services. So it is not limited to only, it will work only if you make a API gateway connection, then you will process that information. So if I want to share an experience or an example, so recently we have been working with one of the pharma related company wherein they have to process the applications of different genetic samples. Okay, so they are working with the genetics data. So what we had to do is, whenever there is a record updated in DynamoDB, okay, that means they added a new entry of the report that is generated based on the genetic information that they got in the laboratory. So we had our Lambda function associated with the DynamoDB. So whenever there is a report generated, okay, by the laboratory, we would send an intimation or notification to the customer saying that your samples are analyzed, we have your report ready, so you can view your report at this temporary URL. So this is a business case scenario how we can use Lambda. So next one is AWS step functions. So step functions allows you to process different operations in sequential form, or I would say different Lambda functions can be clubbed together in step functions such that each function will be executed sequentially. Okay, so in step functions, basically when you I'll give an example how step functions can be used. So if we look at the e-commerce side, there is a checkout process, right? So in the checkout process, there are different information like the billing information, the product information, then the card details need to be pulled, then the real-time payment gateway need to be processed to charge the customer. then create the order of that event, then send a notification to the customer. So if you look at serverless application, these are like different things that needs to be executed at different intervals. Like if I'm taking a billing information, okay, and I'm next step is I want to process the payment. Now let's say if user inputs his card details, but if that card details, the API gateway, the payment gateway is not available for some reason, like the bank servers are down, or the card details that are entered are invalid, or your card is expired. So in such case scenarios, step functions helps you to process whether the request that was made to the payment bank payment gateway is valid, or it send an invalid response, or how you want to process the order. So all these different scenarios are isolated from one another, such that you have different lambda functions which will process different case scenarios, and ultimately finally you process the order if all those case scenarios are valid and it is working fine. So this is how a step function can be used. Yeah, so these are the different layers which you can use while working with serverless. In case if you have more questions, and if you didn't understand any part of it, you can use Q&A sections to put your questions, and our panelists will try to give answers to those questions. Thanks. Now, from the people who are working in who are studying in the university, now you might be thinking like, okay, I have my final year project, I need to work in that project. So the technology what I am working with, will it really help me while working with serverless, or what will be the real-time scenario where in the corporate world what I am learning, will it be useful? So to address that, I have put up the technologies which you can take if you want to work with serverless, or develop or make your career in serverless, AWS serverless. So most of this technology stack is useful one way or the other, but it also depends on the type of project you get. Okay, so first one is Java. So it's a programming language similar to C, where you have your object-oriented programming related skills or procedural programming skills. Then there is a Go. This is a front-end technology. Then Node.js for the backend, if you want to work with Lambda, or if you want to devise your business logic or complex algorithms, you can use Node.js. Similarly, C#, Python, Ruby, then JavaScript, React, or Next. So any of these will be helpful when you want to put your application front end on Amplify, or if you host your application on S3. Okay, then basic HTML, CSS. I'm sure you guys are aware of this. So here I have put different models which we are likely to be using in serverless environment or while working with AWS serverless. So all the HTML, CSS, JavaScript related your front end technologies to build your application will be deployed onto the Amplify. Next thing is, if you want to authenticate the user, that is if he has a valid role to access different services, then you will be using Cognito. Now Cognito actually stores the user information, like when you register as a user, it stores your email, your password securely, and when you want to log in, that information will be used. Similarly, if you want to process the dynamic data, you make a API calls using API gateway, Then if you want to process your information, then you use DynamoDB, and ultimately if you want to store that information in the database, then you use DynamoDB. This is a second model where you host your website on S3. So a very good option which is available in S3 where you can host your website. So you did not rely on Amplify to host your website. So you can make your S3 bucket available on the to host a website, so such that you can point your DNS or domain to the S3 endpoint, and you can visit your site using that domain. So it works similar to what I have explained in the previous model. So here also to make a API calls, then process that information or write your business logic in AWS Lambda, then ultimately store the information in DynamoDB. Now the people who are enthusiastic or want to work with the IoT devices or Alexa or the Echo or different gadgets that work with real-time communication or the different sensors on your actions, what they the ultimate actions that they perform. So for that you can use the serverless application model. So here you give it your chain of commands, that is if you clap or if you give voice commands to shut the lights or to play the music. All that information is captured by Kinesis, and it is then converted into the machine level code that is understood by the device, okay, or the analytics that are performed on the most related information, the command that you have given. So all these things are processed in the Lambda, and using this information. So basically in Lambda you just check if the word what you have said, like the shutdown, whether this shutdown is having any real-time meaning, and it is then converted into the machine learning command, and then it is sent to the actual processing unit where it executes your further process. Okay, so this is a good example of serverless. Okay, so basically now all these devices that the IoT devices, basically what we use, it may not be active at all the time. Like for example, all this Lambda processing or the Kinesis data processing, it happens only when there is an action that you give. Okay, so if there is a idle time where there is no action or where there is no request being sent by the end user, then there is an overall cost that is associated. So in serverless, that additional cost is it's kind of reduced. Okay, so unless you make that request, there won't be any cost associated with that request. So we'll be looking into the benefits of working with serverless in the later stage. So let's just look at what is SAM, or Serverless Application Model. So it's an open source framework offered by the AWS, and it is also offered by some other cloud platforms. So basically SAM is nothing but a code, or you can say a template where you define all your resources, how those resources should act, or what will be different resources you will need while working with your application. So all those resources are defined in YAML or JSON form in the SAM template, and SAM is integrated with the Docker. So when you deploy this entire package, it is then converted into the CloudFormation syntax, and then using CloudFormation, Yeah, yes, Partha, you have anything? You all can hear, right?
Yeah, Siddesh, we can hear you. I think Partha has got some issues while answering to the questions, so he will maybe after the your session he'll answer the questions. Okay.
Okay. Yeah. So, SAM basically helps you in defining all these resources and then provision it on the cloud. So, if you create a SAM one time, same can be used on multiple accounts by running the stack or using the Docker to deploy that entire chain of commands. Plus, SAM also allows you to test different applications locally. That means you don't have to actually deploy every time to test your code or the services what you are using, whether you have permission to access those resources. All those can be tested locally, and you can have the incremental development. That means one by one feature you can release and test and see if it is affecting anything and then deploy it on your uh, main account or where you are hosting your application. So what are the different advantages and benefits which you get in serverless? So first, obviously, there is a speed in deploying the applications. So there is no hardware provisioning, or you don't have to actually work with creating the environment which will be suitable for your hardware or for your application. So all these steps are skipped, and you can directly move on to actually developing the application. So you can quickly build the application and deploy it. Next, you can move to market. That means once you feel that okay, your application is market ready or people can use your application, then you don't have to actually wait for the end product to get complete, but you can directly use the resources that you have created and deploy it on the production. And as and when new requests come to add more features, you can work with creating more APIs, and similarly you can make connection with the same database or same data store, so you don't have to actually create a completely new environment but work with the same environment and provision the resources. Next is cost efficiency. So if you see with the services that are available with server based hosting or server based applications, so you need to pay in advance or at the end of the month the fixed price that is incurred for that entire month, or a predefined price, irrespective of whether you use that service or not. But in serverless, you have the benefit where unless you use any of the feature or any of the service, it won't be charged to you. So if you use a lambda function, then how many times you use a lambda function, only that much is charged. But if your lambda function is idle, then it won't be charged. Same applies to API gateway and other services. So overall cost, if you see, if your application is not in use, you won't be charged anything, but very limited, that is negligible amount. Next is auto scaling. Now tomorrow, as I mentioned in the previous session, like there is too much traffic on your side or too much load on your application, then you need to provision hardware, then make the adjustment in the software, see if there is a new resource you can put to adjust the traffic and all those things. But in serverless, you don't have to worry about all these things. It will automatically scale as per your user base. It will use the underlying hardware based on the number of requests that are made, and the uh, overall processing is much faster, and you don't have to actually give more resources to process your request. There is no server maintenance, as I said, because there is no server actively being used or created by you. All the underlying hardware is already provisioned to you, so you don't have to actually worry about the server. They have their built-in fault tolerance, so you don't have to actually worry if your API is down. It will be backed up somewhere else, or some other data center will make your API available in your application. Then there is a flexibility of resources which you can use. So you need not stick to one type of service to reach meet your ultimate feature, but you can use different services in different way as per your application need. So tomorrow, if I am using one service which is feasible at the moment, I may not use the same service tomorrow if there is another feature that is requiring some higher or good service. Okay, so that flexibility you get while working with serverless architecture. Thank you. I hope that give an overall picture about how serverless works or how you can make a career in serverless and what are the different options that are available when you work with serverless. Thank you.